I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see constraint satisfaction problem for map coloring and color problem. Once again, I welcome the session on CSP mapping and the color problem. Let's explore how constraints shape intelligent problem solving in AI and optimization. Learning constraint satisfaction problem, that is CSP mapping, for the color problem is essential because it is a fundamental concept in AI, graph theory, and optimization. It applies to the real world scenarios like map coloring, scheduling, and resource allocation, where constraints must be satisfied efficiently. The color problem, being NP hard, that is non probabilistic, helps in understanding computational complexity and solving optimization challenges using techniques like backtracking, heuristics, and constraint propagation. It enhances logical reasoning and problem solving skills, making it valuable for fields like AI, machine learning, automated planning, and even compiler design. By mastering CSP mapping, we can develop a strong foundation in algorithmic thinking, enabling us to tackle advanced constraint solving problem effectively. Now we'll see the CSP color mapping problem. First, introduction to CSP and map coloring. A constraint satisfaction problem, CSP, is a already we have discussed this CSP is a mathematical approach to solving problems that involve multiple constraints. Map coloring is a well known CSP problem where each region on a map must be assigned a color while ensuring that no two adjacent regions share the same color. And the goal is to find a valid coloring using the minimum number of colors. This problem can be represented as a graph where regions are nodes and connections between adjacent regions or edges, making it an essential problem in graph theory and optimization. And this is the example problem for map coloring. In this we have taken the Australia's map as a CSP problem. So in this case, here we have various it consists of 7 states and territories: West Australia, Northern Territory, South Australia, Queensland, New South Wales, Victoria, and Tasmania. So here this is the independent one. And the variables we are shortly taking this. This is West Australia is represented as WA, Northern Territory we are representing it as NT, Queensland is Q, NSW, New South Wales. This is Victoria, South Australia, and this we are representing it as T. These values, or we are calling it as the variables domain, we are going to consider three colors. What are all the three colors we are going to take? Red here, and green, and blue. The constraint, what should be the constraint is adjacent region must have different colors. Example, West Australia is having red color. These two, what is the adjacent city states for this West Australia? Northern Territory and South Australia. These two parts should not have the same color. This is the main constraint we have to follow. Adjacent regions must have different colors. So it should not have the same color. This is the first constraint. We'll see. And once again, I'll explain. WA represents the variables I have told you. Know this WA is the West Australia. We are representing it as WA. Northern Territory, we are representing it as NT. This is WA. And South Australia, we are marking it as SA. Queensland, Q or QLD, we can mark it. New South Wales is marked as NSW, Victoria, VIC, and Tasmania. It is not connected with any other states, so this will have any of the three color, either red or three colors we have seen, no? Three colors, red, green, or blue. Any color it will have it. So these states form a graph where each state is a node and edges represent the adjacency. So the map of Australia consists of seven states. Once again, I'll repeat. The map of Australia consists of seven states and territories. West Australia, WA, Northern Territory NT, South Australia SA, Queensland QLD, New South Wales NSW, Victoria VIC, and Tasmania TAS. These states form a graph structure where each state is represented as each state is represented as a node. Like this, we will represent, and edges represent the adjacency between the states. Since Tasmania is an island and does not share borders with any other state, it does not contribute to adjacency constraints, will not have any problem. This structure allows the map coloring problem to be approached as a CSP, constraint satisfaction problem, where the objective is to color the states while ensuring that no two neighboring states share the same color. As I've said, if we are marking it as red, this Northern Territory and South Australia should not have the red color. That is the main constraint we have to consider. What are all the variables and we are using in this cases? Variables, domains, and constraints. In this CSP model, each state in Australia represents the variable. Each state, W, NT, etc. Each state in Australia represents a variable that must be assigned a color. The domain consists of a set of possible colors. Three colors I have said: red, green, and blue. Red, green, blue, which are used to color the map. The constraints ensure that adjacent states do not share the same color. The adjacency relationships between states form the structure of the graph representation, where WA, that is Western Australia, is adjacent to NT. So if you are looking into this figure, this WA is adjacent to NT and South Australia. NT and South Australia, and NT is adjacent to, here again, NT is adjacent to West Australia, Queensland, etc. Is adjacent to SA and Queensland, and so on. Since is isolated, Tasmania is isolated, it can be assigned any color without affecting the constraints because it is not touching with each other. Next, now we are going to solve this problem. Solving the backtracking and heuristics. The backtracking algorithm is used to systematically assign the colors to states while ensuring constraints are met. The process begins by assigning a color to WA, then moves to the next state. So first we are starting from here. We are assigning the color over here for the Western Australia. First, we are assigning the color first to WA, and then moves to the next state, assigning the available color while checking for the constraint violations. If a conflict arises, the algorithm backtracks to modify the previous assignments. Several heuristics helps optimize this process. Minimum remaining values MRV selects the states with the fewest available color choices first. Degree heuristics prioritizes states with the most neighbors and least constraint values. LCW selects the color that leaves the most option open for adjacent states. These techniques helps improve efficiency in finding a valid coloring. Next, visualizing process. If you are visualizing, so in this way, we are doing it in the backtracking. So the MR, minimum remaining values, start with the state with the fewest available colors. The degree of the heuristic, start with the state that has the most neighbors. And LCW represents what? Choose a color that leaves the most options for the adjacent states. And next, coming to the visualizing the coloring process. Visualizing the coloring process, we are going to discuss this. The process of assigning color to the states of Australia follows a structured approach, ensuring that no two adjacent states share the same color. The table shows that this table shows the possible colors for each state at each step, and the final assignments will be based on the adjacency constraints. And how we are going to explain means first state is the Western Australia. Since WA is the first state to be colored, it can be assigned any of three colors available: red, green, or blue. Choosing red does not violate any constraints because no other states have been colored yet. Here, no other states have been not colored. The selection of red for WA influences the color choices of the adjacent states, particularly Northern Territory and South Australia, as they must be assigned to a different color. By starting with the WA, so these three colors are available. WA, we are marking it as a red color. So we are here. I am highlighting this color. Red color. I am taking. So red colors we are highlighting in this case. WA is marked it as red color. So we set the foundation for an efficient coloring process. The algorithm proceeds by considering adjacent states while ensuring that each assignment represents the CSP, respects the CSC constraint. Choosing the red for WA helps limit conflicts and ensure flexibility in assigning color to the other states. Next, coming into the Northern Territory. This is already we have taken over here. The remaining colors are green and blue. Green and blue. And the Northern Territory is adjacent to WA and SA, both of which must have different color from NT. Since WA is already assigned to red, NT, Northern Territory, cannot be this will not be the red because adjacent color is red color already we have chosen, and NT cannot be red, leaving green and blue as the available options. Here we select green for NT to allow SA, which shares borders in multiple states, to have a feasible color choice. And choosing the green for NT ensures that we maintain color diversity while minimizing the chances of conflicts. Since NT, that is Northern Territory, also borders Queensland QLD, its color choices affects the options available for QLD in the next step. So this is okay. Here we are marking it as a green. So I'll be marking. So here green color. Next, the available color is the blue color. So here naturally we are going to mark it as the blue color. And Southern Australia, South Australia, the possible color is only the blue. The final assignment is blue. SA has the most neighbors among the states being adjacent to WA, NT, Queensland, NSW and Victoria. Since WA is red and NT is green, SA cannot use either of those colors. The only remaining option is blue, making it only possible choice. The assignment of blue to SA ensures that all of its adjacent states have at least one valid color left. This demonstrates the importance of the degree heuristics, which prioritizes states with the most constraints early in the coloring process. Next, coming into the Queensland. So Queensland, here already you have given blue, this is green. So this Queensland should not have the value that is color red. So the possible, this should have only the red color. Possible color is only the red because it should not have green and blue. So the Queensland must have the red value. Here I have marked it over here, blue and green. We have marked this leaves red as the only available color for Queensland. The assignment of red to QLD follows the minimum remaining values MRV heuristic, which prioritizes states with the least available colors. See here, MRV starts with the state with the fewest available colors. And by coloring QLD red, the problem remains solvable without requiring additional color. This highlights the least constraint values LCW heuristic, ensuring that adjacent states will have available colors. LCW means choose a color that leaves the most options for the adjacent state. Next, Northern New South Wales. Possible color is only the possible color is green. So we are possible color is green. So here we are marked in the table New South Wales. The NSW has borders with QLD and SA and VLC, Victoria. Since QLD is red and SA is blue, the only remaining color for NSW is green. Assigning green ensures that the adjacency states maintain their constraints while keeping the total number of colors used at the minimum. This step further demonstrates the efficiency of backtracking and heuristics. If a conflict had arisen, the algorithm would have backtracked and reconsidered earlier color choices. However, due to the systematic approach used, no backtracking was needed. Next, Victoria. If you are going into the Victoria, what is the remaining color? It's red. Here it is blue, it is green, and what is the remaining color? Red only we have to use it. Victoria is adjacent to SA and NSW since SA is blue. South Australia is the South Australia is blue. South Australia is the blue value. So it should have what? Victoria compulsorily must have what is the value it should have it. The South Australia is having blue color. Victoria should have the red value. Victoria is adjacent to SA and NSW. Since SA is blue, NSW is green. Victoria cannot be green or blue. The available options are red or blue, and here red is chosen. This decision is made based on maintaining the consistency and ensuring that the minimum number of color is used. By assigning red to Victoria, the algorithm ensures that constraints remain satisfied without requiring an additional fourth color. This step so causes how constraint propagation efficiently narrows down color choices as the process progresses. Next, finally coming into the Tasmania. So if you are going into the Tasmania in the case, what you are going to get, any color we can choose because it is not connected with any other, it is not connected with any other states. So we can use any color to this Tasmania. This Tasmania we can choose. So I am using here blue color. It serves as an example of unconstrained variable assignment in CSPs. Its flexibility make it an easy last step in the coloring process. So coming into the conclusion, the final outcome and observation, the minimum number of colors required to color the Australia map while ensuring that no two adjacent states share the same color is red, here red, green and blue. Correct? The color assignments were made efficiently using backtracking and heuristics, ensuring an optimal and constraint satisfying solution. This structured approach to CSP based map coloring highlights its broader applications in real world problems such as scheduling, resource allocation, and circuit design, where constraints must be met systematically and efficiently. So hope everyone understood this case. Here we are marking it as red. So there are no other options. Here the other options are green and blue. Here we are marking the red because it is not connected with any red. Then we are marking it as red. So green and automatically the other color only Victoria we are marking it as the red because there is no connectivity between this red and this red. So compulsorily we can mark it as the red. And this for Tasmania, we can mark any color because it is not connected with the Australia map. It is a separate island. So these are all the conclusions. And finally, after coloring it, You are getting here, I have written it as green, I have marked it as green, so we can mark it as a blue, any color. Western Australia red means nearby green and blue. Here Queensland is red, and what should be the other option? Because this new South Wales are connected with South Australia and Queensland. South Australia is connected with the red, the blue color. Queensland is connected with the red. So this should be compulsorily green. And Victoria, if you are considering, it is connected with the green and the blue. So this color should be must be red. This Tasmania, we can mark any of three colors: red, green, or blue. I have marked it as green, or we can mark the blue also. Hope everyone understood this CSP map coloring problem. The remaining things we'll discuss in the next class. Thank you.